Okay, everybody, this lesson is on multiplying polynomials. Let's start with a monomial times a monomial, and we'll work our way up to more and more terms. Let's say we have 3x to the fourth times 5x cubed. We want to, all these problems we are just simply multiplying. Well, you don't really have to show this step, but I'll do it this first time here. Everything is multiplied together, so I could just take the 3 and the 5 and rearrange, put them out in front there, and then I got x to the fourth, I got x cubed. And 3 times 5, of course, is 15. And then right here, we learned about exponents in a previous section. X to the fourth times x cubed is x to the 7th, not 12, it is 7. And I multiplied 15x to the 7th. Here's another example. Negative 4a cubed times 3a to the fifth. Okay, even though one of the terms is not in parentheses, it doesn't matter. This is still a multiplication problem. Everything's multiplied together. Negative 4 times 3 is negative 12. A cubed times a to the fifth would be a to the 8th, just like that. Now let's try one more of these. I'll put it down here. 2m squared z to the fourth times 8m cubed z squared. All right, let's see what we have here. 2 times 8 is 16. How many m's do we have? We got m squared times m cubed. That's going to be m to the fifth. We have z to the fourth times z squared. That's z to the 4 plus 2 is 6. And I've multiplied together. Okay, so that's basically how we multiply monomials together. Now what if we have something other than a monomial, like a binomial, two terms? For example, what if we have negative 2x and we want to multiply that to the binomial 8x cubed minus 9x squared? Okay, notice that right here, see, I have that minus that. That's two terms. So what I have to do here, you may have guessed it, is I simply distribute. I have to distribute. Negative 2x times 8x cubed is negative 16x to the fourth. And then distributing over here, negative 2x times 9x squared is a positive, right, a negative times a negative, positive 18x cubed. And I've multiplied the polynomials together. Let's try another one like that. Let's take this one as our example. 5x squared, and we want to multiply that to the trinomial, negative 4x squared plus 3x minus 2. Okay, we distribute again. That's all we do. 5x squared times negative 4x squared is negative 20x to the fourth. 5x squared times 3x is 15x cubed. And 5x squared times a negative 2 is a negative 10x squared. And I've multiplied it. That's all you do. Now, let's take a look at a binomial times a binomial. Binomial times a binomial. There's a couple different ways of multiplying these together. I'll show you both ways here. Let's say I have x plus 3 and I want to multiply that to x minus 2. Now here's one way to do it. What I could do is I could think of, let me erase that. I wanted to do this instead. Okay. I'm going to take that x plus 3 and I'm going to think of it as one single number. Think of it as one number. Imagine this is just one big number here. And I have to multiply it to that x minus 2, so I'd have to distribute it, wouldn't I? I'd have to take this x plus 3 and I have to distribute it there and there, just like I was doing in the previous examples. Now if I write that out, that means I take x plus 3 and I multiply it to x, like this. X plus 3 and then I multiply it to x. I'll put the x in the front. Okay, so I have that times that. But I also have to take the x plus 3 and multiply it to the negative 2, which would be x plus 3 times negative 2. I'll put the negative 2 in the front. Looks better that way. Notice that I have distributed the x plus 3 into x minus 2. Now I distribute again. That's x squared. That's 3x. This is minus 2x. And this is minus 6. And if you have any like terms, you would then combine them, and I do have those right here. That's going to be 1x. So we got x squared plus x minus 6, like that. Okay. Now, I normally wouldn't multiply binomials this way. We would use instead the FOIL method. And here's the FOIL method. You may recall this from elementary algebra class. I do this quite a bit. The F stands for first one, so I go this times this, the first terms. That's going to be x squared. O stands for outer. That's negative 2x. I stands for inner ones, inner terms. That's 3x. And then L stands for last, so 3 times negative 2 is negative 6. And combining your like terms, you're going to get exactly the same answer we had before. Okay, just like that. Let's do another example of a binomial times a binomial. Let's take 4a minus 5, and we want to multiply this to 3a plus 6. If I use the FOIL method, it would look like this. 4a times 3a is 12a squared. Outer ones, 4a times 6 is 24a. Inner ones, negative 15a. And last one's negative 30. And I do have, do I? Yes, I do. Like terms right there. So this is 12a squared plus 9a minus 30. And there it is. Now let's multiply this one the other way as well. Okay. The other way of doing it would be to take this 4a minus 5 and distribute it in. I'm going to multiply it to the 3a, like that. And 4a minus 5, distribute it over to the 6. Multiply to the 6, like that. 4a minus 5 has been distributed in. I then distribute again. 12a squared minus 15a. Over here, I've got 24a minus 30. Combine your like terms, and we have the same answer we had previously. That's a 30 there. Okay, same as before. Now, most people find the FOIL method easier, and that's true. You should probably always use the FOIL method here. So why am I showing you this other distributive method? Well, the reason is, if you had a multiplication problem like, for instance, this one. Suppose we need to multiply 2a minus 5 to 5a cubed minus 6a squared plus 2a minus 3. I need to multiply this together. Now, that has too many terms to use the FOIL method. You can't use the FOIL method here. So you really don't have much choice. You're going to have to use this distributive method. So I'm going to take this, my example, and I have to take that 2a minus 5, and I got to distribute it in there, and there, and there, and there. Okay, so this is going to be a rather long one here, but let's write it all out. So I got 5a cubed times this 2a minus 5. I've got this negative 6a squared times the 2a minus 5. I've got the 2a times the 2a minus 5. And I've got this negative 3 times the 2a minus 5. Okay, so I've distributed that 2a minus 5 in. Your book may show another method where they stack everything vertically, you can use that method as well, though I'm not going to put it in here. But if you prefer that, you can by all means use it. You will get the same result. Okay, now I've got to distribute again. So we got a bunch of terms here. That's 10a to the fourth minus 25a cubed. Over here is going to be negative 12a cubed plus 30a squared. Be very careful with the negative signs. Don't want to miss one here. This is 4a squared minus 10a, negative 6a, and that is 15. Okay. And I should have some like terms here. Let's see if we can find them. Well, 10a to the fourth, that's negative 37a cubed. That's 34a squared. That's negative 16a, and that's 15. And I have multiplied it together. Notice that these things get quite long. Okay, let's try another one where we have to use this FOIL method. Let's say we need x plus 2 multiplied to x cubed minus 3x plus 1. So let's try this again one more time here. I got to take the x plus 2 and I've got to distribute it here and here and here, which would look like this. You got the x squared times the x plus 2. You've got the negative 3x times the x plus 2, and you got this positive 1 times the x plus 2, like that. Distribute again. X cubed, 2x squared, negative 3x squared, negative 6x, 1x, and 2. Combine any like terms that you have. We have right here, that's going to combine the negative 1x squared. That's negative 5x. And over here we've got a positive 2, and there's my result right there. Okay, and this method of distributing would work for even larger polynomials, though we're not going to see any of those here. Okay, let's take a look now at one of these. What would we do with something like this? Well, we've got to multiply all this stuff together. You've got to start somewhere. I think the best place to start would be multiplying those two binomials together first. So I'm going to just leave this 2x squared out in front for the moment, and I'm going to multiply those together. And those are binomials, so I could use the FOIL method if I want. That's x squared minus 3x plus 4x minus 12. If you combine those like terms in there, we have worked this problem down to 2x squared times x squared plus x minus 12, like that. Now it's just a distributive problem. If I distribute in this 2x squared, I end up with 2x to the fourth plus 2x cubed, and then minus 24x squared. And there's my result. All right. Let's look now at some special cases that we come across in multiplying polynomials. You see this pattern a lot. X plus 3 times x minus 3, where the terms are they're almost the same, but one's a plus sign, one's a minus sign. Now this one I could FOIL, so I'm going to FOIL it out. x squared minus 3x plus 3x minus 9 FOILed out. And if you notice here, these two terms in the middle will combine to 0. They're gone. And you're just left with x squared minus 9. Just like that. This pattern, which your book would write something like this, is called a difference of squares pattern. Difference of squares. We'll also see it in the next chapter where we work with it quite a bit. But it goes something like this. If I have a plus b times a minus b, you could FOIL this out yourself to prove it. All you're going to end up with is a squared minus b squared. Here's another example of it. Though you don't have to have this pattern memorized to do this, you just have to FOIL it out. Let's say we have 7m minus 2n, and we're going to multiply that to 7m plus 2n. That's the difference of squares pattern. One's a plus sign, one's a minus sign. And so if I try to FOIL it out, that's 49m squared. That's 14mn. That's a negative 14mn. So these two terms are going to cancel each other out. And that times that is a negative 4n squared. The two middle terms always cancel out in a difference of squares pattern. And here I'm going to be left with 49m squared minus 4n squared. There it is. Okay, so difference of squares, just really the FOIL method. You could just use the FOIL method. Okay, next. This is a very, very common error in algebra class. So please don't make this mistake. Many students will say x plus y quantity squared is x squared plus y squared, like that. And that is a big no. Doesn't work this way. And here's why. X plus y, when you square it, means x plus y times itself. That's what it means. Whenever you square something, you multiply it to itself. Now that multiplication problem can be worked out using FOIL. So I will now FOIL that out. And if I do that, I get x squared. That's an x squared there. An xy. A y times an x is another xy. And then that's a y squared. If you combine those like terms, this is x squared plus 2xy plus y squared. And so notice it's not x squared plus y squared. There's a middle term in there. Okay, so let's not make this common algebraic error. Likewise, if I had x minus y and you squared it, you'd get almost the same thing, except there would be a minus sign right there in front of that 2. These are called, in your book, they're called perfect square trinomials. And once again, you really don't have to have these patterns memorized to multiply them out. I just, as I did up here, I used the FOIL method. Let's do a couple examples of this. Let's say we have m minus 5 and we want to square it. I could simply write it out as m minus 5 times itself, m minus 5. And by the way, I see some students making this error. They think, oh, well, this is, I don't know, difference of squares pattern. One's a minus, one's a plus. No. When you square something, it's m minus 5 here times itself. And one is not a plus and one is not a minus. So let me switch that back. Don't make that mistake here. M minus 5 times itself, FOIL it out. M squared minus 5m minus 5m. That's a plus 25. Combine those like terms, and you've got m squared minus 10m plus 25. Now there's a shortcut for these, and it's actually just using the pattern we wrote down. When I square a binomial like this, and this only works for squaring now. When I square a binomial, all I do is this. I take the first term and I square it. I take the last term and I square it. Should be positive 25. And we know that there's got to be a middle term. And the way you get the middle term is you go m times negative 5 times this 2. Now I know it's an exponent. It's just there it is. It's just something that helps me remember multiply by 2. M times negative 5 times 2 is negative 10 m. And notice I get the same result as before. Okay, so it's a shortcut maybe that I'll mention in class. All right, let's try another. So what would this be here? Let's say we've got 2x, and we have to multiply that by 5x minus 1 quantity squared. We got to multiply that out. What are we going to get? Well, let's start with this right here. What do we get if we square that? I'm going to leave that 2x alone, and I'm going to multiply that together. Remember, that means 5x minus 1 times itself. So I'm going to FOIL. 5x times 5x is 25x squared. Minus 5x plus 1. Combine your like terms. We worked it down to this. 25x squared minus 10x plus 1. You could still use the brackets there. It doesn't matter. Parentheses, brackets, doesn't matter. Same thing. And now we have to distribute that 2x in. And if we do that, times this, times this, times this, we end up with 50x cubed minus 20x squared plus 1 times 2x is 2x. And there's our answer. Okay, one other last multiplication problem here, and it is this one right here. X plus y to the third power. Now, just like before, a common error is for students to say this is x cubed plus y cubed. Once again, that's a no. It does not work that way. X plus y cubed has to be multiplied out. It means x plus y times x plus y times x plus y. 3 times. If it were to the fourth power, you'd have to have another one on there. It gets very long. But that's what this means. Okay, x plus y cubed means that. So if we multiply this out, I'll start with these two. X plus y times x plus y, we did that earlier. This right here turns out to be x squared plus 2xy plus y squared, like that. Okay, that's that right there. Now I need to multiply this x plus y that's left in front times this trinomial. And I'm going to distribute it in. We did a bunch of these problems earlier. I'm going to take that x plus y. I'm going to multiply it to the, let's use green for that. I'm going to take this and I'm going to multiply it to the x squared, which would look like this. I'm going to multiply it to the 2xy, which would look like that. And I got to multiply that to the y squared out here, and that would look like that. Okay, so there's my x plus y multiplied in or distributed into the trinomial. And distribute again. X cubed, x squared y, 2x squared y, 2xy squared, xy squared, and y cubed. You do have some like terms in here. Where are they? Right there. So with this here we got x cubed. X squared y plus 2x squared y is 3x squared y. Those combine to 3xy squared, and we've got a y cubed on the end. And I've multiplied it out. There it is. And take a look. It's definitely not x cubed plus y cubed, is it? It's got a lot more terms in there. Well, 2 more, actually. Anyhow, that's our lesson on multiplying polynomials. See you at the next lesson.